What's up YouTube? Welcome back to my channel, and in this video we'll be continuing with Euclidean geometry, and we'll be talking about theorem number 7, 8 and 9. Actually, let me just write that down because I just wrote only 7 here. So we'll be doing theorem number 7, 8 and 9. Okay, because all those theorems basically talk about tangents to circle, and I just felt like including them in one video will be more helpful than having to put them in different videos. So yeah, without wasting any further time, let's jump straight into the video. So here we normally deal with tangents, as I've already mentioned, and here we're given a radius, or we're given center O, and we're obviously given that radius that meets the tangent. Okay, so for those that don't know what a tangent is, a tangent basically is any line that touches the circle once. Okay, so obviously this would be a chord because it touches the circle twice. Okay, and a diameter is the one that passes through the circle. It touches the circle twice, but it passes through the center, whereas with the chord it doesn't pass through the center. So with a tangent, it only touches the circle once, and it normally lies just outside of the circle in many cases. So what this theorem basically implies is that the tangent to a circle is perpendicular to the radius at the point of tangency, or at the point of contact. Okay, so if we have a radius, in this case it's O, and let me just call this point A. This point is OA, that's a radius, and we have a tangent, let's call it BC. We have that tangent BC over there. So at the point where the tangent and the radius meet, they meet perpendicularly, meaning that they form a 90 degrees. Okay, and that's always the case with every tangent and radius. At the point where they meet, or at the point of tangency, they will always form some kind of like a not even some kind of, but a perpendicular interaction, or intersection, if I can put it like that. I don't know what the word is that I'm looking for, but yeah. So at that point they form an intersection. So so this theorem basically says tan radius, just tan radius. Okay, so the reason every single time you just have to say tan radius, or tan diameter. Okay, so it can be a diameter because diameter is basically twice the size of a radius. It will just be that line being extended further to the other side of the circle. So it could be 10 radius or 10 diameter. But what basically the theorem is saying is that at the point where they meet, they form a 90 degrees. So that's basically it about this theorem. Theorem number 7, it just says that when those two meet, the radius and the tangent meet, they will form a 90 degree. And the converse of this theorem, of theorem 7, basically says that if we have a radius that is perpendicular to a line or a point on the graph, then at that point which it meets that line, we can assume that that line that it meets is a tangent. Okay, so to put it in good words, or in proper words, is that if a line is drawn perpendicular to the radius where through the point where the radius meets the circle, then this line is a tangent to the circle. Okay, so if we're not told that it is a tangent, then we can assume that it is a tangent if they meet perpendicularly at that point. Okay, so in many cases we're told that it is a tangent. So obviously if they tell you that it is a tangent, then this theorem is the one that you should obviously think of, with and other theorems as well, which we're going to discuss. But this is the one theorem that you need to think of every single time they tell you about tangent, the tan radii or radius theorem. So now with theorem number 8, what theorem number 8 basically says is that if two tangents are drawn from the same point outside a circle, then they are equal in length. Okay, from the same point or the point of tangency. So what basically that means, or what that means basically, is that if we have two tangents and the point of tangency, and obviously the point of tangency is point A and point B, where they obviously meet the radiuses, or they touch the circle, then we could assume that those two tangents are obviously equal. Okay, so from this point up until this point, and this point up until this point, then those two tangents are equal. Okay, so this tangent is equal to that tangent. And obviously in many cases with Euclidean geometry, we're basically trying to either find the size of something or the angle. Okay, so that type of information will obviously play a role in you trying to find a certain type of angle. And if you obviously have those 2 points being equal, then you can, let's say for example, let me just give you a good example. We can draw a chord which is AB, and then if we know that AC is equal to BC, then this will be an isosceles triangle, which will obviously feed off to you knowing that this angle is also equal to that angle, and some other extra information that you can find. Okay, so that in itself might not be helpful in terms of obviously using it for just looking at it the way it is, but then you can construct so many things from just that information that can help you find different angles and sides and all that type of stuff. So that is theorem number 8, and to write it down, it basically says that it's tangent from same point, just say PT. It's tangent from the same point basically. So if you have two tangents from the same points, then in which obviously those points are the point of tangency, then we can assume that those two tangents will be the same if they meet again at point C. Okay, so yeah, that's theorem number 8. Okay, so with theorem number 9, which is the last theorem for this video and the last theorem overall, this is one of the most complex theorems. When I was still in high school, I kind of found it very difficult to kind of understand this one, but once I did, it was kind of very easy for me to get. Okay, so and hopefully I do a better job helping you understand it if you already don't. So with this theorem, we're basically saying that if we have a tangent and a chord, obviously our tangent in this case is ABC, and our chord maybe will be AB or BD. Okay, so in this case we'll obviously use, well, not obviously, but we'll use BD. Okay, so if we have a tangent and a chord, and this tangent and a chord form an angle, and in this case it's that angle over there, then we basically saying that the angle between the tangent to a circle on a chord drawn from the point of tangency is equal to the angle in the opposite circle segment. Okay, so that angle which is between the tangent and the chord will be equal to this angle over here. Okay, and to use a different color, that angle, since it's still between a tangent and a chord, it will be equal to this angle over here. Okay, so this one is one of the most common theories and the most complex one. The reason is because they know it's very complex, so they're definitely gonna ask you. Okay, so here we can say that angle ABE is equal to angle BDE, angle BDE, and the reason for that is because of tan chord theorem. Tan chord theorem, or you can just say tan chord theorem. And as I already mentioned, that angle CBD, angle CBD is also equal to angle BED. Angle BED. And same reason, obviously. Same reason as that one. So this is one of the most asked, I don't even know, the most everything. Like, it's always there. You're probably going to see it a lot. You just have to be able to identify it from the example that I obviously gave you here. But once you're able to identify it, it simplifies your life in terms of obviously understanding the theorem overall, and you being able to find different angles. And you'll be told in many cases to find a certain angle, and you'd have to obviously give the reason that it's tan chord. So please practice it as much as you can. And yeah, so that is it for this video, and that is it for this whole series of giving you a summary of all 9 theorems. So please like, share, subscribe, watch this content, and join our weekend classes where we will be dissecting all these theorems with past papers and past examples, and just teach you how to apply them to the course, so that when you get into that exam room, you get in there confidently and you're able to kill it or nail it, to put it like that. So that is it from my side. Please don't forget to like, share, subscribe, tell your friends about it, and join our weekend classes. So cheers guys, I'll see you in the next video.